Hello everyone. Today we are going to discuss about Python application programming concepts. According to syllabus, we will be discussing about classes and objects, classes and functions, classes and methods. In particular, we will be discussing about programmer defined data types, attributes, rectangles, instances as return values and few characteristics of objects. In classes and functions, we are discussing about time, pure functions, modifiers, prototyping versus planning, debugging. In case of classes and methods, more of object-oriented features and printing the objects. Few examples related to the classes will be discussed, and we will also be discussing about type-based dispatch, polymorphism, and interface and implementation concepts. Let us start with classes and objects. We all know how to use functions. Basically, functions are used to organize the code. And we have built-in types which is used to organize the data. Here, in the next step, we are going to learn about object-oriented programming concepts where it uses programmer defined data types or types to organize both code as well as the data. In case of programmer defined types, there are many built-in types we find in Python. We are going to now define a new type. As an example, we will create a type called point. This is used basically to represent a point in a two-dimensional space. In mathematical notation, points are nothing but they are written in parentheses along with the comma. Okay, separating the coordinates So if we try to represent the points, we will be representing it as 0, 0, close the parenthesis. It is parenthesis along with comma separating the coordinates. Okay, say for example, if I tell x, y, this represents the point x units to the right and y units from the origin. Okay, so there are several ways we might represent. Ways to represent points in Python are as follows. First, we could create the coordinates separately in two variables, namely x and y. Second, we could store the coordinates as elements in a list or tuple. And we also could create a new type to represent the points as objects. That means we can create a new type, and creating a new type is a complicated job, and it has some advantages as well that we will discuss in the next coming topics. Now here, when we consider A programmer defined types okay, so it is also called as class. Fine. So when we try to analyze the definition, it is going to look like, say for example, we have class point. Okay, so this class point, it represents a point in two-dimensional space. Correct? So here let me consider that I have a class object which is defined. The object diagram can be shown like this. Here I have a blank and the object is point, okay, which comprises of two coordinates. X refer to some coordinate point 3 and y refers to coordinate point 4, okay, and this corresponds to the blank. Okay, the syntax normally we use to define class is given as here class followed by the name of the class, next initializers, attributes, methods followed by the statements. The class object is considered to be like a factory for creating the objects. Okay, so here to create a point, we try to call the point as if it is like a function. So a point is functioning like a it's working like a function. Okay, so consider this example. Here we have a blank. Blank is a variable which we are assigning with the point. What does a point comprises of? It comprises of x is assigned with some value and y coordinate with some value, and this is assigned to the blank. Okay, so the return value here is a reference to this point object. Okay, so the object whatever we consider which we assign is that is to a, the reference is considered to be a blank. Okay, now what is instantiation? Okay, so if at all I am creating a new object, I call it as an instantiation. Okay, here the object is an instance of a class. Fine. So whenever you are printing an instance in Python, Python tells you what class that this object is belongs to, okay, and where exactly it is stored, maybe in the memory. Fine. So here when you consider this 0x, okay, it is the you can call it as a prefix. Okay, so 0x prefix which is basically giving you the memory location address with an hexadecimal value, okay, regarding the memory. Fine. So 0x means here we are considering it is to be an hexadecimal address, okay, which is followed by the address. Fine. Next, for every object, okay, if at all you consider that every object is an instance of some particular class, okay, so the object and the instance are interchangeable. Okay, I repeat, every object whatever you call it is an instance of a class. Okay, so object and instances are interchangeable. Okay, but now we use instance to indicate a programmer defined type. So consider this example. Here I have created a class object, my first program, and in that the statement defined as print welcome to object oriented programming. Now I am going to assign this class to a variable C. When I print C, the content or the statement which has to be executed or which is there in the my first program class will be displayed. The output would be something like this. First, when you print, it will display welcome to object oriented programming, and it will display, for this is taken from which object? It is a my first program object which is located at a memory address location of your computer memory. Next, we are going to discuss about the next concept called attributes. Here, you can assign values to instance using the dot notation. Okay, so we can assign the values. Consider that I have blank dot x assigned with some value, blank dot y is assigned with some value. Okay, so this syntax is almost like a syntax for selecting a variable from a module. Okay, say that you have something called as math dot py, or we also have string dot white space. Okay, so here these modules almost like the syntax is similar, right? So in this case, though we are assigning the values to the elements of an object, okay, so these elements are called as attributes. Okay, so these elements are called as what? Attributes. Fine. Next, we have a diagram which shows the result of these assignments. Okay, a state diagram which shows an object and its attributes. Okay, which is called as object diagram. Okay, so the variable here blank refers to the, you have used the variable, correct, which is that variable blank. Now what is that blank? Blank is referring to what now? It is referring to a point object. Okay, so this contains two attributes. How many attributes it is having? It is having two attributes. So each attribute refers to a floating point number because we have chosen the decimal numbers, that is floating point numbers. Okay, and you can read the value of an attribute using the same syntax. Okay, say that if I give blank is equal to point object and blank dot x is defined as 3.0, blank dot y is defined to be 4.0. Okay, and the expression blank dot x here, what it means? It is meaning to that it go to that specific object blank, okay, which refers to blank, that is a point object. Okay, you just go to the specific object and get the value of x. Okay, so here blank dot x, okay, it means that go to that particular object, get the value of x. Here in the example it is getting the value of x, which is nothing but 3.0. Okay, so there is no conflict here between the variable x and the attribute x. Okay, so you can easily identify and you can analyze. Fine. So you use dot notation as a part of any expression. Fine. So consider that we make use of percentage g, percentage g. Okay, so here blank dot x or p dot x, p dot y, basically this is an way that you try to print the values in terms of floating point numbers. Okay, so the result of this, if you try to see, it would be like 3.0 comma 4.0. Okay, fine. So let us talk about the next concept. Like here we can also pass an instance as an argument. Okay, normally like in usual way how we try to pass an argument, like that you can pass an instance as an argument. Okay, say for example, I have a class which is nothing but a point. I have defined print underscore point. Okay, so this is a it's a function that you are calling it or using it, which way to which you are passing an argument. Okay, now here the argument what you have taken is self comma p. Okay, so the sprint underscore point, it takes an argument and displays it in mathematical notation. Okay, so whatever that you have given, that is a print point, it will take it and display it in the mathematical notation. So in order to invoke this, you can pass the blank as an argument. Okay, so when you try to print, say for example, if I give print underscore point of blank, okay, then you can see this result, right? 3.0 comma 4.0, that is 3.0 and 4.0. Okay, so depending on the value or the function, you can make use of these things. Now inside the function we could see that p, correct? So p is an alias for blank. I repeat, p is an alias for blank. Okay, so if the function modifies the p, the blank also tries to change. Okay, so whenever you are changing the value of p, automatically blank will change, because p is nothing but it is aliasing the blank. It is also a point object. Okay, so consider that you have an exercise, okay, where you have to write a function which is called distance between the 2 points, and take those 2 points as arguments and return the distance between them. You can take it as an example and you can do that specific operation. Okay, so here we have seen assigning the values, okay, and passing the instance as an argument inside the object. Okay, now this is one more where you are, as I told you, p is an alias for the blank. So whenever you are using p dot x and p dot y, it is pointing to the blank, right? Because you have referred blank is nothing but a point, and the variables which you are assigning the coordinates with 3.0 and 4.0, and if you make it blank dot print underscore point of blank, then the result would be something like this. Okay, 7 comma 9, which means that you have already defined the print underscore point as with an argument which is passed by self comma p, right? So p here is nothing but acting like a blank. Now whenever you are using p dot x plus is equal to 4, so which means that this is added with the x plus 4. Okay, so x is a value which is having 3, so 3 plus 4 is what now? 7. So 7 will be now updated with the value of x. Okay, similarly y plus is equal to 5, so y is already having a value called 4 plus 5, which is equal to 9 and assign to y. When you try to print this, okay, then the result would be 7, 9. Now we are going to discuss about rectangles. Okay, so sometimes we think that the attributes of an object has to be it should be there, but other times no, you have to make some decisions like what to choose. Say for example, here imagine that you are designing a rectangle. Okay, so when you are designing the rectangle, it is obvious that you create a class to represent the rectangle. Okay, and what are the attributes you would use to specify the location, and you can call it as a size of the rectangle. Okay, so sometimes you can even ignore the angle. Okay, to make it simple, you try to assume that rectangle is either vertical or horizontal. Correct? To let me keep it quite simple. Okay, so now there are at least two possibilities. Okay, so you could specify the corner. You could specify the corner of the rectangle, the width or the length. Okay, so okay, let me call this as the length and this is the width. Okay, and you could also specify the opposite corners. Okay, fine. So at this point now, when we are discussing about designing a rectangle, definitely it is very hard to say like which is better. Correct? So if you have the length and the width, it is also a good one, and if you have the corners, yeah, you can also design a rectangle, right? So now consider that I am going to define a class. Now this is a class which is defined in the name of rectangle. Okay, so what happens? It represents a rectangle. What are the attributes that we have used here? Okay, so this doc string, it is going to list all those attributes. Okay, where I've used width, height, corner. Okay, so these are the attributes which width and height are representing the numbers. Okay, and corner, it represents a point object. Okay, so it basically represents the lower left corner. Okay, so which corner it is representing? It is representing the lower left corner. Okay, now consider that to represent a rectangle, we have to first instantiate the rectangle object and assign some values. Correct? No? So to the attributes, we have to assign the values because we have chosen these kind of attributes like width, height and the corner. First, now let us take box is equal to rectangle. You are assigning it to a box and you are providing the values for it. That is box dot width is 100. Okay, height is 200 and you are giving the corner to a point object. Okay, say that I have, this is my rectangular object. Okay, so let me write, this is a rectangle which is assigned to a variable called box. Okay, what is the width of this? Width of this is 100.0. The height of this is 200.0. Okay, and the corner is, it is referring to a point object. Okay, so where the corner is x to 0 and y to 0. So this is a point object. Okay, now with this, when we try to assign, so box dot corner dot x, okay, box dot corner dot y, which basically means that go to the respective box, object called box, okay, and select the attribute which is named as corner, okay. Go to this box, select the attribute named by corner, and then go to the specific object, okay. Select the attribute which is named x and assign the value as 0, okay. Similarly for the other one, y to be 0, okay. Now let us talk about instances as the return values, okay. So we know that the functions can return the instances. Say for example, I have find underscore center, okay. It is having an argument, fine. It is taking rectangle, that is rect. It is an argument and it is returning a point, okay. It is returning a point. Basically that point contains the coordinates to create the rectangle, okay. So which is nothing but it is giving the coordinates of the center of the rectangle, fine. So here we have defined find underscore center is a function with an argument passed as rectangle, and we have chosen a point to a variable p. P dot x is considered to be as a go to the specific point with an object x, and that object is nothing but rect dot corner dot x. So it is assigned with the value that is x, okay, plus rectangular width, rectangular corner of specific value x plus the width divided by 2. Similarly, rectangular corner value y with the rectangular height divided by 2, okay, because I am just trying to find the center of my rectangle, okay. So this is my rectangle, correct. So by knowing the corner of x and y, okay, so by knowing the corner, don't you think that I can find out the center of your rectangle? Definitely, okay. So this could become a center. Now in order to do that, what I do, I take up this x corner, okay, plus the width. As I get the center of the rectangle, which is returned from the function, that is we have defined the function as find underscore center of rectangle, and the value which is returned is a p. P is pointing to a point object, right, which is returning the x and the y value coordinates, okay. Now here is an example. Let me consider that I just want to pass the box as an argument, okay, and this is going to assign the resulting point to the center. So consider that we have defined center is equal to find underscore center of box. Box is an argument which we are going to pass it to the function find center, okay. So when we print this, print point of center. Okay, so this is going to result with the center values of the rectangle. That is, if I consider this is my rectangle of x and y, width and the length. Okay, so the center point of that will be chosen and displayed. Okay, now let us continue the next topics in the next session. Thank you all.